Okay, we're back, and as you can see, we're going to eventually get to OSPF, and I just was reviewing part of the video I just shot a couple minutes ago. I just want to make sure that everybody understands that this won't be identical. Hang on one second. That this won't be identical to the topology that we have, or you guys are going to be working on. So, I'm going to wait to the what's the word I want to use? It's already been recorded, produced, is it? I don't know. Upload, okay, we'll just go with upload. I'm going to wait to upload it until the end of April, because the fact that, well, it's not like you guys couldn't go out online and, find this information for yourselves, but the whole purpose of this lab is to see what you guys know how to do. I'm recording this because of the fact that I want to make sure that I know how to do everything before I take my CCNA, which is actually on April 2nd, which is also he'll be 4 on that day. It's my son's birthday. So hopefully we'll come out with 2 wins. He'll be 4 and I will have a CCNA. So only time will tell. Anyhow, a lot of this stuff has to do with understanding what's going on. So right now, what is going on? Well, as I said in the last video at the end, I said that I said that I was going to set it up to where you, whoopsie. Actually, let me keep that minimum. There, that's better. I was going to set PPP up. Now, I already have recorded a PPP video. So, in that regard, I'm not going to really have to do a whole lot. So what we're going to do is I'm going to show run interface serial 0/1, and that's our PPP. So serial 1, what I'm going to do is I'm going to go to move this to serial 0. So I'm going to copy this, and I'm going to go to global config mode and type in interface serial 0/1, and I'm going to paste this. So this already does this. So what you do is you hit up, you control A, you type in no clock rate, enter, type up again, and you hit control A, no encapsulation, and do one more, and for the IP address, control A, no. So what that does is it allows me to go to interface serial 0/0 on router 4 and paste, and then end. So now, if you wait just a moment, we should get connectivity on both sides, because we're on the same connection at this point. So, hopefully. And, oh, duh. Config T, interface serial 0/0. No shut. That probably would help. There, it's changed up. We have connectivity across. So that's a good thing. So now I can go show IP interface brief. If I could type. And now we have 172.20.0.169. And serial 1 is still up, which is okay. We're going to ping 172.20.0.170. And we can talk to it. And we're going to do the same thing over here. Ping 172.20.0.169, and we can ping across. So pinging works across the board, so we're good to go there. So what I'm going to do is I'm going to go into both interfaces and turn off the IP address. And just watch. Interface serial 0/1, no IP address. And config T, interface 0/0, no IP address. Well, why'd you do that? Well, I'm going to turn it into a multi-point connection. We've just set up PPP, so we know that works. So what we're going to set up as a multi-point. So what we're going to do is we have serial 0, or we're going to do it on R4 first. Serial 00 and serial 01 are both actually already encapsulated. Well, let's see, interface 00/1 on R4 and type in encap PPP to re-encapsulate it. I didn't think about that before I did it. So what we're going to do is they're both in the same bundle. They're both encapsulated PPP. So we're going to do, well, yeah, and do show run interface 00/0 encapsulation PPP 0/1 encapsulation PPP. Good deal. I'm going to go to global config mode, type in interface multi-link 1, enter. We're going to type in IP address 172.20.0.1 69 255.255.255.252. Then what we're going to do now, it's been configured. That's all you have to do with the interface. So we're going to do the same thing over here. We're going to do end show IP or show run interface 00/1. We know that guy's in PPP, or do 0/2. This guy is not running PPP, so we're and it's shut down. So we have to go in config t interface 00/2 encap PPP no shut. And so then we know it may not squawk, but okay, it did. So now we have connectivity across because there's a PPP circuit. So what we're going to do now is we're going to go in and we're going to type in exit, type in interface multi-link 1, and we type in IP address is going to be 172.20.0.170 255.255.255.252. So now we know it's up. Okay. Let's type in no shut just for added measure. And no shut. You know, it might be, you know, I bet you any money it's down just for the fact that there's nothing in it. So what we're going to do is we're going to go into interface serial 0/1, type in, what is this? What's the command? Forget interface multi-link. Oh, I can't remember what it is. I just did it yesterday. Oh, I know. It just hit me. PPP multi-link group 1. There. I'm going to type in interface. See, it changes it down and it brings it back up. 0/. Where was I in? 0/0? 0/1. 0/0. Type in PPP multi-link group 1. Whoop. Space. Weird one. So there. And then we're going to type in end. And we're going to type in show IP interface brief. And then we have multi-link is down. That's not a problem. So we're going to go and we're going to say interface serial 0/1. Type in PPP multi-link group 1. Interface 0/2. Interface, well, we're already in the PPP multi-link group 1. So now the multi-link came up, as you can see, and we're good to go. Type in end, show IP interface brief, and should be at the bottom, and there it is, it's up. And, oh, show IP interface brief, and it's up. So I should be able to ping 172.20.0.170 from here. And we can ping across. ping 172.20.0.169. We can ping across. Now, let me show you a little cool thing that I like to. We use these at work where I work a lot. Show interface stats. It lets you see what's going on, because then at this point you'll be able to see that it should be load balancing across. R4 doesn't have any fast Ethernet information going on, but it should theoretically be load balancing for the most part across both interfaces. Show interface status, or actually statistics. And fast Ethernet's pretty busy on R1. So it's receiving ARP information. 0/1 and 0/2. They'll catch up, but what it's going to do is it's going to send information across both links at the same time. So what you actually can do is you can get in there and you can do per packet load balancing on PPP. That's way beyond anything in the CCNA level. But I just wanted to give you guys an idea of what you guys could actually do when it comes to getting this set up. So I'm going to set up an interface over here. I'm going to give this something random. It'll be the 17220 range, but on R4, and I forgot what, and that'll be fast 0/0, I think it is, right? Yeah. So I'll go ahead and I'll jump into global config and I'll type in interface fast 0/0, and I'll type in IP address is going to be 172.20.0. Give it. I can't even think off the top of my head right now what the range should be. We'll give it 1, and we'll go. We'll do a /25. So there. That's where that goes. And I'm also going to do this other thing. I'm going to set it up for DHCP, and so that anything down here that we configure will pull a DHCP automatically. So what we're going to do is we're going to type in IP helper. Oh, is it helper address? Helper address. Question mark. And it's like, well, what is that? IP helper address, if you don't know what this is, what this does is it takes any DHCP requests that come in on this local LAN on this interface, and it ships them up to R1, which is where the DHCP pools are going to be configured. So we're going to point it to 172.20.0.170, because it knows how to get to. We'll put it at 170, and because that'll be this interface right here, and that's that. And show run interface fast 0/0. IP helper address and then 172.20, so that anything that comes in on here, it should be able to ping. We're going to ping 172.20.0.170 from a source of fast 0/0. And I'm getting nothing. Oh, you know why? Because it's not. That's my own fault. It knows how to get this. Knows how to get here, but this guy doesn't know how to get there. So what we're gonna do is when we set up OSPF, we'll do that and get that situated. But that's how that'll work. And the same thing with R3. And I don't want to capture. I want to console. I'm just thinking here how I should do this. You know, I'll give them /32s or /27s. So we're going to go to global config, type in interface fast 0/0, type in IP address is going to be 172.20.0.1. I gave that 128, so I'll put this .129 and be 255.255.255.224. And Okay, not a problem. Not an issue at all. So what we're going to do is, instead of 129, we'll give it, let's see, 254. 254. Right? Yeah, that'll work. And type in IP helper address. It's going to be 172.20.0.137. And then end write mem. So, okay, what is that going to do? Well, I gave it an IP address range at the end, so we're in 0.254. I'm going to drop down, this is 32 addresses right here, or 30 addresses on 224, so I'll drop that down to, I'll do some quick math and I'll put something on R2. But I have a DHCP helper, so anything that comes in as a request, that'll take care of it in R2 console. And we're config T, type in interface fast0/0, type in IP address is going to be 172.20.0.32. Let's see, 254, 255, 255 minus 32 will be, what's that? 224, right? 223. We'll go 223 and type in 255.255.255.224. Bad mass for 223. Okay. 222. I had to think, I'm thinking here, 224 is going to be the base network. 222. There. And then IP helper address is going to be 172.20.0.137. And write mem. There we go. So now what we're going to do is we're going to exit on this guy, and we're going to go back to R1, and we're going to turn on OSPF. We want to get the routing going, because in order for these guys to learn this stuff, we have to get it set up for it. So we're going to go into global config mode, and we're going to type in IP or router OSPF1, type in network, type in 172.20.0.0, type in 0.0.0.255, because we're only focused on the one range. Type in area 0. That's all you have to do. And then what we're going to do is on okay, what this will do is OSPF will only run and forward packets for the network 172.20.0.0. Like, well, how do you know that? Well, OSPF doesn't advertise out a interface that it is not configured to advertise out. So if you don't have this IP address range somewhere on one of the interfaces of the router, it's not going to advertise OSPF it's not going to advertise out for advertisements or for adjacencies is what I was actually trying to say. So R1 is done. R4 comes up next, and we're going to come in and we're going to type in config T. We're going to type in router OSPF 1. Oh, how about I would spell router? Control U. Router OSPF 1. Type in network 172.20.0.0.0.255 area 0. Area 0. Enter. And if we did anything right, we did. We did. And you're like, well, what's that 192.168.1.106? Well, by default, OSPF will automatically set a router ID of the highest configured physical interface that's on the router, or the highest logical or loopback IP address that's configured, unless you go in and you configure a router ID for the router. I knew that. Did I do it? No, just because it doesn't matter. Well, it could, but it's not. It doesn't. So we're going to ping 172.20.0.170 from source of fast0/0. It's amazing that it pinged. How does that ping? Because it knows how to get there, because there's a route. Show IP route. And we should have one adjacency. And we do. 172.0.136/29 on 170. That's how we get there. So, how do we get frame relay to, how do we get, we're going to write mem by the way, and how do we get OSPF to work on over frame relay? Well, that's where we're gonna set this up, and this can get kind of tricky. So config t, type in router OSPF1, type in network 172.20.0.0 0.0.0.255 area 0. Okay, now I'm going to leave that open. That didn't work out too well, did it? R3. I'm going to leave that sitting right there, just so you guys can watch. Config t router OSPF1, type in network 172.20.0.0 0.0.0.255 area 0. Lovely weather we're having outside, isn't it? Yes, it is, actually. And show IP route. And show IP route. How come nothing's coming up? We can ping our neighbor, right? Ping 172.20.0.139. Oh, 138, I should say. Oh, it would help if I gave it the right IP address. Well, we'll just let that phase out. We can ping our neighbor. It's a little slow, but we can ping our neighbor 172.20.0.138. Oh, I'm trying to ping myself, but I can't. Yoo-hoo. 139. I can talk to my neighbor. But how come I can't ping, or how come OSPF isn't working? Well, a little known fact about OSPF. It doesn't work really well across NBMA networks. So one thing we're going to have to do, we're going to have to set it up to talk to our neighbors. So we're going to go to R1. And R1, we're going to type in, so it's loading with 169, so we know that that works. We're going to type in neighbor, question mark, 172.20.0.138, question mark. Priority of non-broadcast neighbor. We're going to give it a priority of 0. We're going to click on config t, well, over here on router 2, I should say. Router 2, we're going to go to config t interface, interface 00/0 dot. This is router 2, so it'll be 201. Type in IP OSPF priority question mark 0. You do not want these guys to become a DR or BDR. you want this guy to be your DR. Well, to act like it anyway. Config T. We're going to type in interface 00/0. Got too many slashes in there. 0.301. Type in IP OSPF priority is 0. And we're going to do the same thing over here. And priority here is 0. And we're going to do the 139. Priority 0. But what we're going to do here, we're going to exit, type in router OSPF, Control U, router OSPF 1, neighbor 172.20.137, and then we're going to question mark, and we're going to say unrecognized command. Well, hey, what do you know? It worked. It came up. Golly gee willikers. I didn't know that would work. I didn't know it would work. That's why I'm kind of like, you guys need to know this. So, did I kind of dance around the bush a little bit? Yeah, just a little. So, R1. Now, we type in end. We do a show IP route. This is the only time you have to be worried about it. And guess what? Now we have routes everywhere. So what I'm going to do is, now that we have routes, that's going to be the big thing. Is if you don't have a route somewhere, that's where you're going to get hosed up. So, and show IP route. And the one thing about OSPF is you have to be patient. It's like BGP. If you ever configure BGP or ever work with BGP, once you just because you have once you get your neighbor relationship set up from autonomous system to autonomous system, so let's say that, actually let me do a show IP route just so you guys can see this. More of my proof is in the pudding type of a situation. Let's, just for kicks and giggles, we're just going to drop R1 down here. Well, I'm going to drag it over off to the side. You guys can't see it right now. But this is basically how it's going to work. Is R1, we're going to pretend is Autonomous System 1, and R3 is Autonomous System number 2. Or let's go with R3 is AS3. In BGP, what you're going to do is you're going to set up a neighbor relationship based on, typically you're going to configure a loopback, but let's say you don't configure a loopback. You're going to peer with it using your neighbor statement. Let's say remote AS and the autonomous system, and then you're gonna peer with it. Give it a minute, it's gonna come up, and then any network statements or any networks that you want to advertise into BGP, you would have to type in network and then the network name or the network number, and then that would kick in. OSPF is kind of the same way, in the same regard, where you can turn it on, but until you go to the hub router and you can tell, you tell it that it's, what do you call it? What's the word I'm looking for here? Its neighbors are not going to have any chance of becoming a designated router or a backup designated router. That's the only time that you're going to be able to get it to converge. Now, I didn't have to really worry about doing anything with configuration because I knew what was going to happen. It was just a matter of actually getting it to work. So what I'm going to do is I'm going to ping 172.20.0.169. I can talk to that guy. What about 170? I can talk to 170 as well. Now the one thing I won't be able to do is I won't be able to talk to the 192 network. And you're like, well, why? If you look right here, it's connected. It should work, right? Well, let's try. 192.168.1.1. And you're like, well, wait a minute. That shouldn't be. Well, is it? We haven't redistributed static routes into OSPF. R1 knows how to get there because it's directly connected. Ping 192.168.1.1. Right? one thing we haven't done is we haven't redistributed a default route into OSPF. And I will do that right now. So what we're going to do is we're going to go to global config mode, and we're going to type in router OSPF 1, type in default question mark information question mark originate. That's going to distribute a default route. Question enter. Now that's on R1. That's on this guy right here. He's connected to it. So R3. Type in show IP route. And guess what? We now know it's an OSPF external route via 0 route via 172.20.137. So can we ping 192.168? 192.168.1.1? Now we can. That is something you need to know how to do. It's going to use the OSPF process that's currently running as your routing protocol, and it's going to say, okay, I have this static route, or this default route to get to here. Well, this is what you guys are going to use. If you don't know how to get somewhere that isn't already advertised, this is how you're going to get there. So we can do this, we can ping that, and we're going to source it from our fast0/0 interface. Completely say what? Show IP interface brief. Oh, I didn't turn it on. How about that? Config T interface fast0/0 no shut. How about that to come back in and bite you in the butt? So end. I'm going to type that command in one more time. And now anything from this network right here should be able to ping out here. Now let's, since we're on R3 already, where's R3? We're going to trace route. 192.168.1.1. It's going to hang. I don't know why it's hanging. Let's kill that. Let's go trace to 8.8.8.8. Oh, you know why? I know why. I know why. Simple. It's because this guy isn't going to take a private IP address and NAT it. So, it's not going to work. So ping 8.8.8.8. Well, how come we can ping it? Different type of ICMP. That is why. So that's done. We have frame relay running. We have OSPF running. We have PPP running. We have routes. We have default routes being redistributed, I should say. That pretty much covers everything. Now I need to go through this guy right here and figure out what we need to do next, because it's kind of pointless to keep going if we don't have anything to work with, right? But what I'm actually going to do is I'm going to go through this thing and I'm going to do a couple things. And actually I got a NAT. I've got a NAT. I don't want a NAT, but I have the NAT. You guys need to learn how to do that, or it needs, at least need to be shown the correct way to do it. And I mean, it's really not that hard. You're just going to set up a inside and outside interface and go from there. It's really straightforward and simple. Nothing complicated. Oh, I have to set up DHCP as well. So we're going to set that up at a different point in time and go from there. So, with that being said, I hope this has been informative for you, and I would like to thank you for viewing.